quadratic inequality. We've got a negative 2x squared plus x is less than or equal to negative 6. Let's see. What we want to do is if we've got a quadratic anything, we want the one side to be 0. So let's move the 6 over by adding 6 to both sides of the inequality. That will give us a negative 2x squared plus x plus 6 now is less than or equal to. Everything canceled, but I still have a 0 on the right. Now the question is, how do I graph something that looks like this? There are several options. We do still want to figure out where this thing is going to cross or equal 0, cross the x-axis or equal 0 first, so that we can know what the parabola kind of looks like. So first of all, I want to know about where 2x squared plus x plus 6 equals 0. Now, if you're not sure how to factor something like this, you can use the quadratic formula. It will always work. It's just really up to you. I tend to always try to factor if I can. However, most students don't like the fact that there's a negative out in front. But again, it's up to you. To factor it by hand using the old methods is you take the negative 2 times the positive 6, which is negative 12. And you'd be looking for two factors of negative 12 that add up to the middle number, a positive 1. That would be a positive 4 and a negative 3. Then what that allows you to do is it gives you a way to break up that 1x. It tells you how to break up the 1x into two pieces, a 4 and a negative 3. So it would tell you to break that up into a positive 4x and a negative 3x. Everything else would stay the same, so you'd still have your negative 2x squared and your positive 6. And then what this lets you do is do grouping now at this point once you've got 4 terms, which means group the first two. What do they have in common? Well, they're both divisible by 2. They both have an x, and we also want to pull out the negative sign. So we're going to pull out a negative 2x, which will leave me with still having another x on the first piece. Be careful, though. You pulled out a negative with your 2, so this positive is actually going to turn back into a negative 2. Remember, you divided out of 2, so the 4 will turn into a 2. Let's do this all over again with the last 2 here. We have, let's see, they're both divisible by 3. Also, again, you have a negative on the first term, so let's pull out the negative. So let's see what that gives you. If you pull out a negative 3, that will still leave you with an x minus 2. And if you remember this from way back when, now that you have a matching x minus 2 here, you can factor out the matching x minus 2, which will leave you with the negative 2x minus 3. And again, this whole thing equals 0. Once it's factored in equals 0, then you can go ahead and set each piece equal to 0. And on the first piece, we'll add 2 to both sides and get 2. On the second piece, we'll add 3 to both sides to get negative 2x equals 3. Then we'll divide both sides by a negative 2, which gets us that x equals negative 3/2, which is actually a nicer number. It is, let's see, negative 1/2. Remember, these two values are where you're going to cross your x-axis. So that means you're going to cross your x-axis at a positive 2 and a negative 1/2. Notice this time, though, your parabola has a negative 2x out in front, which means your parabola is going to be pointing downward from the first time because it's got a negative coefficient. The question is, what were we looking for on this one? We still wanted the same thing. We wanted to know when this thing is less than or equal to 0, meaning when is it below the x-axis. So this means what part is below the x-axis. Well, notice there's two parts of this, or two pieces that are below the x-axis. There's this piece, and then there's this piece. Well, the first piece, working from left to right, goes from negative infinity to our first value. So let's see, that one will start out at negative infinity and work ourselves up to the first value, which was negative 1.5. And the second piece starts at the second value, which was 2, and works its way all the way over to the right to positive infinity. This time, as a reminder, we had less than or equal to in our original problem. The equal to means we're going to use brackets also for the first time. And then we need our little u, or union, to unite those two pieces, and that's our interval notation and our final answer for what parts of our parabola are below the x-axis, less than or equal to 0. And that's our final answer. So the next thing that we're going to do is looking at solving other inequalities. Remember, inequality in section 1.7, we're going to